Welcome to Notes 1.6, Simplifying Radicals. This is for Algebra 1. The goal of this video is for you to be able to take a radical and break it down into a simpler form. So if you read at the top, it says, in order to do any operations on radicals, you must know the first 15 perfect squares by heart. You don't technically need to know only the first 15. If you know more than that, that is great. The more of them that you know, the better off you will be down the road. Okay, so let's start filling in all the perfect squares that we know. We'll start with 1 squared. 1 squared is 1, and a common mistake on that is that people will multiply 1 by the exponent and get 2, so be careful of that. 2 squared is 4. And so what I would like you to do right now is to pause the video and go through without a calculator and try to fill in all of the perfect squares that you know. And for those that you don't know, please leave blank. When you're ready, unpause the video and we will see how you did. What I would like you to do now is to fill in any of the blanks that you didn't know. And then what I would like you to do is to circle those numbers so that you know what you should be focusing on as far as memorization. We begin with the example of the square root of 80. And what we have here are a number of steps that you can use to simplify radicals. And what I would like you to do is, if you ever forget how to simplify radicals, go back to this page in your notes and reference these steps. And so the first step says to factor the number under the radical sign if possible, so that one of its factors is the largest possible perfect square. So the number under the radical sign is 80, and so we will be factoring the number 80. And so what I'm going to do is I'm going to list the perfect squares that are factors of 80. The first perfect square that is a factor of 80 is 1, and so I know that I have 80 because 1 is a factor of any real number. Now the next number we have is 2. And 2 is a factor of 80, but I'm not going to include 2 because 2 is not a perfect square. But I will include 4 because 4 is a perfect square, and I'm only going to include perfect squares. So 4 is a multiple of 80, and so if I use 4 over here, I will have 20 because 4 times 20 is 80. The next perfect square we have is 9, but I'm not going to include 9 in my chart because 9 is not a factor of 80. The next perfect square after that, if you look at our chart, is 16 because 4 squared is 16. And so I would include 16 in our chart. And 80 divided by 16 is 5. Now I'm going to keep going with the perfect squares until I get to the halfway point of 80. And the halfway point of 80 is 40. 4 squared works, which was 16. Now 5 squared, which is 25, would not work because 25 is not a factor of 6 squared is 36, which is not a factor of 80. And 7 squared is 49, which is more than the halfway point of 80, so we won't include it. So the largest perfect square that we have is 16, so we're going to use 16 and 5 as the factors when we're simplifying the square root of 80. So step 2 says you're allowed to split up a radical sign if there is multiplication underneath it. So the problem is the square root of 80, and so I'm allowed to say that this is the square root of 16 times the square root of 5. You could also say root 16 times root 5 or radical 16 times radical 5. And so step 3 says evaluate the square root of the perfect square and leave the other factor underneath the radical sign. So 16 is a perfect square, and so we end up getting 4. Now since we've done the square rooting, we don't put the square root on. Even though 4 is a perfect square, we've done the operation, we've done the square rooting, and so we don't need to include the radical sign anymore. So now we have 4 times the square root of 5 because 5 is not a perfect square. We can't take the square root of that, and so we have for our answer 4 times the square root of 5. So let's look at something real quick. Let's say that on accident you used 4 and 20 instead of using 16 and 5. So you didn't pick the largest perfect square. And so what we would have is the square root of 80. And then you would use, instead of square root of 16 and square root of 5, you would have the square root of 4 and the square root of 20. Now when you take the square root, you don't need the square root sign anymore, and so you would have the square root of 4, which is 2, and you would have 2 radical 20. So notice in our final answer, we had radical 5. Now 5 is not divisible by any perfect square. So this is my final answer. 20, however, is divisible by a perfect square. And that perfect square is 4. So we're going to split up the radical 20 as radical 4 times radical 5. And just remember, the 2 gets copied down. In our next step, the 2 just gets copied down again. The square root of 4 is 2. And then we just copy down the square root of 5. And now we just multiply together the 2's, and we get 4 radical 5. And now we're done. And notice we have the answer that we had previously. So you can do either method and you'll still get the same answer. The drawback to doing the method on the right, where you don't pick the largest perfect square, is that you will have a little bit more to do with simplifying that radical, and you have to make sure that you simplify it all the way. Our first method has much less work. You just have to make sure to remember to find the largest perfect square. Okay, so let's try a few examples. Let's look down here at number 1. We have the square root of 200. So the first thing that you're going to always ask yourself is the number square rootable? Because we're only going to try and simplify numbers that are perfect squares. So 200, for example, is not square rootable. It's irrational, and so we're going to take the square root of it by simplifying. So the way that we do this is by using the steps we did before with the square root of 80. We're going to find what perfect squares is 200 divisible by. Well, 1 works because any real number is divisible by 1. The next perfect square that works is 4. And when we divide 200 by 4, we get 50. 3 squared is 9, and 200 is not divisible by 9. 4 squared is 16. 200 is not divisible by 16. 5 squared is 25, and 200 is divisible by 25. And when you divide 200 by 25, you get 8. 6 squared is 36. 36 doesn't work. 7 squared is 49. 49 doesn't work. 8 squared is 64. 64 doesn't work. 9 squared is 81. That doesn't work. But 10 squared is 100. 100 is an option. 200 is divisible by 100, and when you divide, you get 2. And we've reached the halfway point, and so our largest perfect square is 100. And so what we're going to say is that radical 200 is equal to radical 100 times radical 2. And so we end up getting 10 radical 2 as our final answer. And the reason we got 10 is the square root of 100 is 10, and we cannot take the square root of 2, and so we left it as the square root of 2. Okay, question number 2. We will ignore the 5 for now, and we'll move over to the square root of 27. And 27 is not a perfect square, so we cannot take the square root of it, which means that we will have to apply the steps that we've learned so far to simplify it. So what I would like you to do right now is to fill out your chart for 27. Please press pause and then come back to me when you have found the largest possible perfect square. So you should get that the only factors of 27 are 1 and 27 and 9 and 3. And so we should use the 9 and the 3. And so the square root of 27 is going to split up into radical 9 times radical 3. And so now the question is, what do you do with the 5? Well, just like what we did with the 2 above with the square root of 80, we're just going to copy it down. And so we can't do anything with the 5 yet, so we're going to bring the 5 down again. Square root of 9, 9 is square rootable, and so when we take the square root of 9, we get 3. So we have 5 times 3, and the square root of 3 is just going to tag along. And so what we have is 5 times 3, which is 15. And so our final answer is 15 times radical 3. Okay, number 3, we have radical 17. 17 is not factorable. It's not a perfect square. And 17 is prime. And so if we were to fill out the chart, we would have the only perfect square that works is 1. So we would have 1 and 17. There are no other perfect squares that 17 is divisible by. And so in this case, our final answer is radical 17. We cannot simplify that any further. Number 4, down below, actually next page for you, I believe. What I would like you to do is press pause. Please try this one on your own, and when you are ready, come back to me and we can compare answers. Okay, with number 4, what you should have done is you should have looked for perfect squares that 52 is divisible by. Because it's not a perfect square, you can't just take the square root right off the bat, so we have to simplify it. The only factors, the only perfect squares it is divisible by are 1 and 1, you get 52, and 4, and you get 13. So as with one of the previous questions, what we will do with the 6 is just bring it down for now, and the square root of 52 will break down into the square root of 4 times the square root of 13, and the reason that we are using 4 and 13 is because 4 was the largest perfect square that was a factor of 52. I still can't do anything with this 6 yet, so I'm going to bring the 6 down. The square root of 4 will give us 2. And remember, you don't need the square root sign because you have already square rooted the 4. And 13 is prime, so we're just going to bring down the 13. From here, all we need to do is to multiply the 6 and the 2. We will get 12, and it's times the square root of 13, and so our final answer is going to be 12 radical 13. If we look at number 5, one of the first things you want to do with all of these is check to see if you can take the square root right off the bat. And at this point you can take the square root. It is a perfect square. The square root of 81, hopefully you know this, it is 9. And so there's nothing else we need to do. There's no more simplifying. Because it was a perfect square, we didn't have to follow those other steps. Our answer is 9. Okay, that is all for now. Thank you for watching the video. Please stay tuned for the question, and I will see you in class.